Now let's continue generalizing roots to roots that have indexes greater than 2, and we'll practice with division. Now the idea we're going to use is if our roots have the same index and they're real numbers, and b isn't 0, because we would end up dividing by 0 then, which is undefined, then we can write the root of the quotient as the quotient of the roots. And again, notice that the indexes all have to match. Now once we do that, we can often simplify an expression. For instance, here I have the fourth root of 81 divided by x to the 8th. And by that quotient rule, I can write this as 2 fourth roots. So I'm rewriting the root of the quotient as the quotient of the roots. If I prime factor 81, it turns out to be 3 to the 4th. And now I can use my division idea. 4 goes into 4 once, so a factor of 3 will be outside. And 4 goes into 8 twice, so a factor of x squared will be outside. And I don't need any more radical symbols. Try this one. First, I'll use the quotient rule. Then I'll see negative 27 as negative 3 cubed. Starting in the dividend, 3 goes into 3 once, so there'll be a factor of x in the top. And for the divisor, for the base of negative 3, 3 goes into 3 once, so there'll be a factor of negative 3 in the bottom. It's common for people to write this negative dash out front here. It's exactly the same thing mathematically, but for some reason people like this look. How about here? First I'll use the quotient rule. Then I'll see 16 as 2 to the 4th. In the numerator, 4 goes into 7 once, so there'll be a factor of m outside, with remainder 3, so there'll be an m cubed inside. For the base of 2, 4 goes into 4 once, so I'll have a factor of 2 outside. Try this one. First I'll use the quotient rule. Then I'll see negative 64 as the quantity negative 4 cubed. In the numerator, 3 goes into 3 once, so I'll have a factor of negative 4 outside. In the denominator, 3 goes into 9 3 times, so I'll have a cubed outside, and I'm done. And here's our last one. First, I'll use the quotient rule. Then I'll see negative 32 as the quantity, negative 2 to the 5th. In the top, 5 goes into 12 twice, so I'll have an r squared outside, with remainder 2, so I'll have an r squared inside the 5th root as the radicand. In the bottom, 5 goes into 5 once, so there'll be a factor of negative 2 outside, and no factors in the radicand. Once again, it'll be common for people to bring this negative 2 dash up to the front like this. Well, that concludes this video, where we had a little practice dividing roots when indexes were greater than 2.